Hello guys, we are Team Prompt from Thailand and this video dedicated to our robot soccer team. But first, let's start with our members. Hello, my name is Pavit Nathian Thasawat. I'm the MC of this video. Also, I'm the programmer due to my experiences in regional competition, including the WRG 2024 Soccer Robot 1x1. I am the person who is most familiar with the movement of a soccer robot, so the role become mine. Here's our team leader.
Hi, my name is Warwet Nakrom. My nickname is Atom.
With experiences of being a team leader from many competitions, also he's the oldest, and his thoughtful approach and ability to remain calm under pressure help keep the team focused during competitions. He's the most suitable for being a team leader. The next person here is our robot builder.
My name is Thanyavut Kitkanun. My nickname is Khawpan.
My soccer robot duo. We competed in the WRG 2024 Soccer Open 1x1 together. He took the lead as the robot builder, designing and assembling the entire robot. His innovative approach and the attention to detail ensured the robot was both functional and efficient on the field. Thanks to his hard work, we were able to create a robot that could perform complex tasks like dribbling, maneuvering, and kicking with high precision. With his design, in the end, we were proud to win the first place. The last person here is our document designer.
My name is Vishal Khonsap and my nickname is Gain.
Decorator, information gatherer, and experiences for many decorated documentation works, this role suit him the most. We're competing in RoboCup Junior Soccer Open category. So the first thing we have to do is build two great footballers. And then we sprinkle some code for them. And next step is to teach them some technique. Then we get two great footballers. But before any of that, we need to build the real robots. First thing we have to do is the robot design. So we assign Vishayawat to gather equipment that suits us the most. So we get the first thing we get is Shihai motor, 980 RPMs, powerful motor with high torque, enabling rapid movement toward the ball and strong resistance against opponents. The second thing we get is GTF Omni Wheel, high quality omnidirectional wheels that enable smooth and precise 360-degree movement, improving agility and maneuverability on the field. The third one is OpenMV, Python Power Vision module with built-in machine learning support, runs object tracking, color detection, and feature recognition effortlessly via UART. The last one is BNO 055, 9-axis absolute orientation sensor with onboard sensor fusion, provides direct ruler angle and quaternion via I2C or UART, ensuring precise motion tracking without complex calculations. For the electronic part, we get the first thing we get is ESP32S3 Romeo, multiple UART, I2C, and digital ports, plus 4 motor ports, enable clean and efficient hardware connections without messy wiring. The second thing we get is light sensors by BC Programming, high accuracy sensors that clearly differentiate between white and green areas on the field, ensuring reliable detection. The third one is step-down converter, efficient voltage regulator to ensure stable power delivery to all components, preventing overheating or damage. And the last one, motor driver, dual H bridge, motor driver that allows smooth and precise control over the Shihai motors, supporting bidirectional movement and speed adjustment for the dribbler. Our robot consists of 4 motors, 9 light sensors, a BNO gyro, and an OpenMV camera. And this is the full wiring diagram. Starting with 12 voltage battery through a switch box, pass a step down, and separate to the motor driver at the main board. And after we put all the wires together, we hope it's not gonna explode. For the first sub-assembly part that we use is conic mirror. Expand the field of view for vision-based applications allowing the OpenMV camera to capture a 360-degree perspective. The second one is acrylic stand for conic mirror. Securely hold the conic mirror in place, ensuring proper alignment for accurate vision processing. The third one is Y connector. Provide a power source to two power sources, one for the main board and one for the motor driver, ensuring clean connections and reducing the risk of loose or tangled wires. The last one, switch box, provides an organized and accessible control interface, allowing safe and efficient power management. For the structure of the robot, we use ABS filaments. Durable material used for 3D printed parts, ensuring strong yet flexible components for structural and functional designs. And here's the demonstration of how to build the robot. And here comes the problem. The dribbler cannot fit in front of the robot, so the builder come up with an idea. Here. In this way, when the dribbler dribbles the ball, the dribbler rotates counterclockwise, and when the robot is going to kick the ball, the dribbler rotates clockwise, making the gear that is connected with the kicker here rotated, resulting in a powerful kick without losing any spaces. And now we're here at the coding part. As you can see here, from the first line to line 14, we include all the library that we need, continue with the PID value, and all the hardware ports. Many variables are also here, like speed, position, and time. And next, in voice setup, we start both serial for data read and for camera input, along with the pin mode of the motors, and also we reset the gyro before the robot starts to move. After that, throughout the code, the robots follow the ball and kick the ball into opponent's goal, following the ball using X and Y value of the ball by using X value for the direction and Y value to tell the robot whether the ball is in the front or behind it. Then we put them into these equations to make the robot move towards the ball, but also avoid the white line on the field using the light sensors around itself. The light sensors are also used to letting the robot know when it's gonna have to kick the ball. For the AI that we use, of course we use ChatGPT for programming consultation to simplify the code and also the conic mirror design. But sometimes we might still miscommunicate with AI. Even we're being careful, it can still give us wrong suggestions that don't fit our need. So we learn to verify and test them before using them, making our development process more efficient.
After we explain everything about our robot, here we are at the end of the video, the knowledge sharing part. We think that the most important thing about building a software robot is to find appropriate hardware that suits our usage. For instance, the reason that we use ESP32S3 Romeo to be our main controller is because of its orderly wiring. It has all ports that we need, so we don't need to be worried about extension board. Also, teamwork is a very important aspect of a team. With heavy workload and limited time, we need to divide work to each member of our team well and work together until the task is completed. And that's a wrap up of our project. We hope you gain some valuable knowledge and know more about our robot. Thank you for listening and following along with us. And lastly, see you in Singapore.